TNPSC Combined Statistics Services Exam Unit 2. Our today's topic is Chebyshev's inequality. Chebyshev's inequality interprets the role of standard deviation as a parameter to characterize variance. It is defined as if x is a random variable with mean mu and variance sigma square, then for a positive number k, we have probability of modulus of x minus mu greater than or equal to k sigma is less than or equal to 1 by k square. Or we can say that probability of modulus of x minus mu less than k sigma is greater than or equal to 1 minus 1 by k square. Notice that modulus of x minus mu greater than or equal to k sigma is the total of two tail probabilities. That is, the difference of the random variable from mean is greater than k times the standard deviation. Such points occur at the tail of the graph or they are the extreme values. The probability of such a point is less than or equal to 1 by k square. The most important point about Chebyshev's inequality is that it makes no assumption about the shape of the distribution. No matter what the shape of the distribution, it does not consider the shape of the distribution. Now let's substitute the values for k. When k is equal to 2, we get that the chance that x is at least 2 standard deviation away from its mean is at most 1 by 4. And similarly, when we substitute for k is equal to 3, 4 and 5, we get the chance that x is at least 3 standard deviations away from its mean is at most 1 by 9, and for 4 standard deviations away from its mean is at most 1 by 16, and at least 5 standard deviations away from its mean is at most 1 by 25. Now, if we take k sigma is equal to c, which is greater than 0, then the equation of Chebyshev's inequality becomes probability of modulus of x minus mu greater than or equal to c is less than or equal to sigma square by c square. Or we can say that probability of modulus of x minus mu less than c is greater than or equal to 1 minus sigma square by c square, where sigma square is the variance. Now let us see the generalized form of Chebyshev's inequality. Let g of x be a non-negative function of a random variable x. Then for every k greater than 0, we have probability of g of x greater than or equal to k is less than or equal to expectation of g of x divided by k. This is the generalized form of Chebyshev's inequality. Now, when we replace g of x by modulus of x in the generalized form of Chebyshev's inequality, we get Markov's inequality. That is, probability of modulus of x greater than or equal to k is less than or equal to expectation of modulus of x divided by k. This is Markov's inequality. And now, when we replace g of x by modulus of x raised to r and k by k raised to r in generalized form of Chebyshev's inequality, we get the generalized form of Markov's inequality. That is, probability of modulus of x raised to r greater than or equal to k raised to r is less than or equal to expectation of modulus of x raised to r divided by k raised to r. Now let us see certain questions related to Chebyshev's inequality. Question number 1. For the set of values, the percentage of values that lies within population mean plus 4 standard deviations of the population is dash percent. The answer is 93.75%. Question number 2. The theorem which states the role of standard deviation as a parameter to characterize variance is dash. The answer is Chebyshev's inequality. Question number 3. Considering the set of observations, the percentage of values that lies within population mean plus 2 standard deviation is dash percent. The answer is 75%. Question number 4. A class of second graders has a mean height of 5 feet with a standard deviation of 1 inch. At least what percent of the class must be between 4 feet 10 inch and 5 feet 2 inch? The answer is 75%. Note, the heights that are given in the range above are within 2 standard deviations from the mean height of 5 feet. Question number 5. Computers from a particular company are found to last on average for 3 years without any hardware malfunction with a standard deviation of 2 months. At least what percent of the computers last between 31 months and 41 months? The answer is 84%.